In this video, I am going to teach you aromatic, anti-aromatic and non-aromatic organic compounds. First, you should know the meaning of conjugation. First, there must be double bond, single bond, double bond. Second, double bond, single bond, positive charge. Third, double bond, single bond, negative charge. And fourth, double bond, single bond and lone pair of electron. For example, you take these organic compounds. Now see this structure first. There is double bond, single bond, but at this carbon atom, there is no positive charge, no negative charge, or there is no lone pair of electron. Means this compound does not contain conjugated cysteine. Second, this compound, there is double bond, then single bond, and oxygen has two lone pairs. One is, this is third, one is outside the ring and second inside the ring. So outside the lone pair of electron which is present outside the ring, it does not take part in conjugation. So only one lone pair is considered. So 1, 2, 3 double bond, single bond and a lone pair of electron, means it follows fourth rule, double bond, single bond, lone pair. So this organic compound contain conjugated cysteine. Next one, double bond, single bond and then double bond. So this compound follows the first rule, double bond, single bond, double bond. Next compound, double bond, then single bond, then double bond. But this compound has one lone pair which is outside the ring, which does not take part in conjugation. So this compound follows the rule, first double bond, single bond, double bond. So this is conjugation. Now you take another examples. First double bond, single bond, again double bond. Means it follows the first rule, double bond, single bond, double bond. Next example, double bond, single bond and lone negative charge. So it follows the third rule, double bond, single bond and negative charge. Next, double bond, single bond and positive charge. So it follows double bond, single bond and positive charge. And next, double bond, single bond and nitrogen has lone pair of electron which is present inside, which take part in conjugation. So it follows the fourth rule, that is double bond, single bond, lone pair. Now we'll distinguish or identify the aromatic and anti-aromatic and non-aromatic compound. First you write, first aromatic and anti-aromatic must fulfill these conditions. It must be cyclic. Second, conjugated system. And third one, planar 2D shape and sp3 carbon which is connected to another carbon atom by double bond. If it satisfy all these conditions, then we can say that the compound is either aromatic or anti-aromatic. For non-aromatic, the conditions are not cyclic, not conjugated system, not planar. For example, these are the compounds. First, it is a cyclic, then double bond, single bond, double bond, means it is conjugated. So it is an example of aromatic or anti-aromatic. Next, it is a cyclic compound, double bond, single bond, negative charge. So this is the conjugated system. So it is an example of aromatic or anti-aromatic. Third, the compound is not cyclic, means it is not it does not contain conjugated system. Next one is cyclic compound, double bond, single bond. But at this carbon atom, there is no positive charge, there is no negative charge, there is no lone pair of electron. So it is an example of non-conjugated system. It is non-aromatic. Next, how to find out the aromatic and anti-aromatic compounds. So some tricks to find aromatic, anti-aromatic and non-aromatic organic compound. First you write for aromatic 2 and for anti-aromatic 4. So 2 plus 4 gives 6, 6 plus 4 gives 10, 10 plus 4 gives 14 and so on. So it follows 4n plus 2 pi electrons. So this rule is known as a Huckel rule. 4 plus 4 is equal to 8, 8 plus 4 is equal to 12, 12 plus 4 is equal to 16, means it follows 4n pi electrons. So with the help of these pi electrons, we can identify the given organic compound whether it is aromatic or anti-aromatic. Now you should remember for double bond 2 electrons, for negative charge 2 electrons and lone pair of electron 2 electrons. These are the examples. So you have to identify the aromatic or anti-aromatic organic compound. First, it is a cyclic compound. Double bond, single bond, double bond means conjugated system. Now the given compound contains 2 double bonds and for each double bond you can consider 2 electrons. So 2 plus 2 is equal to 4 means it is an example of anti-aromatic. Next one, it is a cyclic compound, double bond, single bond and then negative charge. So this compound has conjugated system. There are 2 double bonds, so we can write 2 plus 2 and for negative charge you can write plus 2, so total is a 6. So it is an example of aromatic organic compound. Next one, it is a cyclic compound, double bond, single bond and positive charge. So it has a conjugated system. There is one double bond, so we can write 2. So 2 means it is an example of aromatic. Next one, it is a cyclic compound, double bond, single bond and then negative charge. So it has a conjugated system. There are 2 double bonds, so we can write 2 plus 2 and for negative charge we can write 2, total is a 6. So it is an example of aromatic. Next, additional examples. Cyclic compound, double bond, single bond, positive charge means it has a conjugated system. There is one double bond. So 2 is equal to 2 means it is an example of aromatic. Next, cyclic compound, double bond, single bond, negative charge. Conjugated system, there is one double bond. So you can write 2 and for negative charge you can write 2. 2 plus 2 is equal to 4. So it is an example of anti-aromatic. Next one, it is a cyclic compound, double bond, single bond, positive charge, conjugated. Next, there are 2 double bonds, 2 plus 2 is equal to 4. It is an example of anti-aromatic. Next one, it is a cyclic compound, double bond, single bond and double bond. So it has a conjugated system. So there are 3 double bonds. So we can write 2 plus 2 plus 2 is equal to 6. So it is an example of aromatic compound. Now we'll discuss the bicyclic compounds. These are the examples. Cyclic compounds, double bond, single bond, double bond. There is a conjugated system. In all, there are 5 double bonds. So 2 plus 2 plus 2 plus 2 plus 2 is equal to 10. So it is an example of aromatic compound. Now check the next example. No doubt it is a cyclic compound. Double bond, single bond, again double bond means conjugated system. In all there are 4 double bonds. So 2 plus 2 plus 2 plus 2 is equal to 8. So it is an example of anti-aromatic. Now we'll discuss the decreasing stability order of aromatic, anti-aromatic and non-aromatic. So the given is the decreasing stability order for aromatic, non-aromatic and anti-aromatic organic compounds. Means aromatic compounds are more stable than non-aromatic than anti-aromatic. Now these are the examples. First, it is a cyclic compound. Double bond, single bond, negative charge, there is a conjugated system. There is a one double bond and negative charge. So 2 plus 2 is equal to 4. Means it is an example of anti-aromatic. Next, cyclic compound, double bond, single bond, and this carbon, there is a no positive negative charge or lone pair of electron. So not conjugated, means non-aromatic. Next example, it is a cyclic, double bond, single bond and negative charge, means there is a conjugated system. So 2 plus 2 plus 2 is equal to 6, means it is an example of aromatic. So in this way we can identify the aromatic, anti-aromatic and non-aromatic compounds. Thank you.